Hello everybody. It is my great pleasure to present the work on performance evaluation of lead-free CS2Cu SbCl6 perovskite solar cells achieving 21.67% efficiency. Now these are the session outlines. First we will discuss the introduction, then the proposed device design. Moving forward, we will discuss about the results and finally the conclusion and references. In this 21st century, with the population boom, there has been an immense demand for energy. Traditional sources of energy, such as fossil fuels, offer energy, but also at the same time contribute to greenhouse effect, which negatively impacts our environment. Huge research is being conducted to find alternative sources of energy. The solar energy is a renewable energy, and the solar cells, also known as the photovoltaic cells, appear promising because they generate energy from the sunlight, which is abundant and renewable in nature. In our study, we have researched about the lead-free perovskite solar cell, which can be used as a potential replacement for the current lead halide perovskite for photovoltaic applications as a non-toxic alternative. We have evaluated the performance of CS2Cu SbCl6 based lead-free perovskite solar cells in this work by mainly altering the thickness of the absorber layer and thus comparing the efficiency obtained. CS2Cu SbCl6 offers various advantages. It is flexible, it is a lead-free perovskite, so it's non-toxic, and it has a wide and indirect bandgap of 1.7 volts. Also, it maintains higher power conversion efficiency and absorbs the extra photons. The perovskite cells are mainly developed for the photovoltaic applications. Now this is the device structure of the proposed CS2Cu SbCl6 solar cells. The front contact is the indium tin oxide. The electron transport layer is the titanium dioxide, that is TiO2. Now the absorber layer is the lead-free perovskite, that is CS2Cu SbCl6. Now the whole transport layer is Spiro-OMeTAd and the back contact is gold. Now coming forward to the results. From the figure 2a, which represents the JV characteristics of CS2Cu SbCl6 solar cells for different thickness of the absorber layer, it is observed that when the absorber layer thickness is increased from 700 nanometer to 1300 nanometer, then the JV characteristics decreases. Now this happens due to the reduction in electric field and increase in charge recombination. Thus, it is found that for 700 nanometer thickness of absorber layer, it is the most suitable for highly efficient lead-free perovskite solar cells. Moving forward, now the figure 2b shows the quantum efficiency of the CS2Cu SbCl6 solar cells. When the absorber layer thickness is increased from 700 nanometer to 1300 nanometer, then the quantum efficiency slightly reduces, which is reflected in the figure. Now this highlights the impact of the absorber layer thickness on the photovoltaic parameters. Now this figure shows the performance parameters for different absorber layer thickness of the CS2Cu SbCl6 solar cell. Firstly, discussing figure 3a, as the absorber layer thickness increases, the VOC, that is the open circuit voltage, decreases, which is highlighted in figure 3a. Now figure 3b shows that the current density, that is the JSC, slightly increases with the increase in the absorber layer thickness. Figure 3c, which shows the fill factor versus the absorber layer thickness, shows that for 700 nanometer thickness, we have obtained the fill factor of 83.81%, and as the absorber layer increases, the fill factor decreases. Now finally, figure 3d highlights the power conversion efficiency versus the absorber layer thickness. Now it is found out that for 700 nanometer thickness, maximum power conversion efficiency of 21.67% is obtained. Now this is due to the high absorption of the absorber layer, which absorbs more photons of higher wavelength. Coming to the conclusion, in the present work, the CS2Cu SbCl6 lead-free perovskite solar cells has been proposed for photovoltaic applications. Thereafter, we have studied the variation in absorber layer thickness to gain optimized results. After optimizing the CS2Cu SbCl6 absorber layer thickness, it is found out that for 700 nanometer thickness, the absorber layer and the solar cell will produce the maximum efficiency. The maximum efficiency obtained is 21.67% as proposed for the 700 nanometer. The other performance parameters include 1.242 volts for open circuit voltage, 21.75 milliamperes per centimeter square for short current density, and 83.81% for the fill factor respectively. Thus, the optimized value of 700 nanometer of the absorber layer can be considered helpful for the fabrication of lead-free perovskite solar cells for photovoltaic applications. These are the references used in our study. Thank you very much for listening to my talk, and please feel free to submit any questions for me to answer in due course.